I want to pick up where we left off the last time, but before I move on, I want to talk about that last problem that we were doing. Let me turn this down just a little. Okay. We were talking about this problem on the bottom of page 1 here, and I want to talk about this last statement here. So let's pick up on this problem. It says, when the account balance is $250 or less, you earn interest at a linear rate of 10% per year. So linear rate meaning simple interest. And so I use the A of t of the simple interest, which is K or P times 1 plus IT. That applied for t less than or equal to 15 because I figured out that it takes 15 years to get to 250. And then I'm assuming that you're going to take the 250 and reopen a new account. Okay? That was an assumption we made, and you, sir, you were a little not too happy with that, right? Yes or no?
With me?
Yeah.
I thought it kind of made, I was a little confused, but it kind of made sense afterwards.
You know why you felt that? It's because I'm assuming here that I'm taking this 250 and sticking it into a brand new 8% account. So let's label that as such, okay? And I'll put it in red. So this is assuming that you are going to reopen bank account. But that was assuming that you would reopen the bank account, right? But nobody said that. So can you tell me what the balance would be if I didn't reopen the bank account? No one said reopen it, right? So I don't have the right to take out this 250 and say 250 parentheses 1 plus the new interest rate times the number of years. I don't know if I have the right to do that because no one said pull out the 250 and reinvest, right? Go ahead, sir.
Would it just be 100?
Yeah, 100 where though?
Instead of the 250.
Okay, but what about the fact that there's already 250 in there?
But aren't we? But if you're just leaving it in, wouldn't you still use 100 as the loan?
I'm leaving it in there, but at time 15, you have $250 in there. So whatever I add has to be added to $250 because this is asking for AK of T. What is AK of T? It is the amount in your bank account at time T. Let's say T equals 20. So I can't ignore the fact that it's already 250 at time 15, and it's never going to be less than 250 because it's already 250 at time 15. So I better build that 250 in, right? So what I'm asking you is, can you give me a statement here that tells me what my balance is at time T, given that at time 15 there's $250 already in there? Yes. So you want to go 250 plus what? 100. Right, so 100 times 0.08 times the number of years that it's been in there past 15. T minus 15 for T greater than 15. see if that makes sense to you. I'm saying that at time 15, there's $250 in there. And now this 250 is going to grow at the simple interest rate. The simple interest rate based on $100. 8% interest for this many years. So if T is 20, then it's growing at 8% for 5 years. Do you agree with that? You must have some feeling about what I'm saying, right? Yes.
Why is it only 0.08 and not 1 plus 0.08? They multiplied by.
So I'm saying that every year past 15, it will gain 8% interest on 100. So this 1 plus is, this 1 was there because we're saying the amount in the account is 100, the original principal, plus the interest. But my original principal is not 100. My original principal is 250. So I've taken care of that 1 plus part already, right? Because I dare not say that it's $100 because it's not. It's 250. Follow me? That's why the 1 plus part is missing. Any question? So this would be the case if it remained in the same account. Any question? Still talking about the most basic case, which is simple interest. Okay? Yes.
Can you just explain again why it's T minus 15, like how we know?
Okay, so this problem said up to 15 years, when the balance reaches 250, you have a 10% interest rate. But past 15 years, you have an 8% interest rate. And how do I know it's 15 years? Because I solved for when is the balance going to be 250.
So you need to like specify it.
Yeah, so after 15, something different happens than before 15. Follow me? Any question? Let's go to the next page. Okay, so it's telling you now do the same thing for compound interest. When your account balance is 250 or less, you earn interest at a rate of 10% per year. Otherwise, you earn interest at a rate of 8% per year. Find the amount function AK of T. Can you try, please? Give it a shot. Now it's not simple interest, it's compound interest. Let me ask you, what is A of T, lowercase a of T, for compound interest? Compound. What is lowercase a of T? Somebody tell me what this is.
1 plus I to the T.
Right. 1 plus I to the T power. Okay, so can you build it now? Can you build this AK of T like we did for simple interest? Can you do the same thing for compound interest? What did we do the last time? We went and solved for the t such that you hit 250, right? Can you do the same? This is why I asked you to bring your calculators. You better solve for that t that makes it happen, right? So I want to say this, okay? A am I starting with $100? It says K equals 100. So A 100 of T equals 100 times 1.1 to the T. And I want to solve to see when that hits 250. Do you agree? Can you do that, please? Let's divide by 100. 1.1 to the T equals 2.5. Now what? What do I do? Yeah.
Natural on both sides.
Yep. T, ln of 1.1 equals ln of 2.5. Solve for T. T equals ln 2.5 over ln 1.1. And what do you get? Let's do it. Ln of 2.5 divided by ln of 1.1. 9.61. T equals 9.61. Okay, now what? Yeah.
Would you have to round up since you don't get that $250 until the 10th year?
Why? This is compound interest continuously.
Okay.
Okay, so you don't drop the decimals or anything. It's saying 9.61 years, finished. Okay, so go ahead. Build me a of t function. A 100 of t equals what? The first part is easy because it's 100, 1.1 to the t, for t less than or equal to 9.61. Then what's the second tier? This is a tiered function, right? What's the second part of the tier? How much is in my account at 9.61? Yeah, 250. 1.08. T minus what? Exactly. And that's the function for t greater than 9.61. Are you in agreement? Okay, I want to show that AK of t is not equal to KA of t. So what is A of t? Why am I doing this? I am doing this because on the previous page it said that normally AK of t is KA of t, but not for tiered functions. Look, to see when AK of t is not equal to KA of t, consider all these different functions that have tiers, right? So I'm trying to show that in this case, it's not. So can we come up with KA of t and show that it's not equal to AK of t? I already know what AK of t is, where k is 100, obviously, right? So I want to show that it's not equal to 100 times A of t. So let me come up with my A of t function. What is it? That's my question. A of t equals, start with 1, because little a assumes that you're starting with $1. A of 0 is 1, right? So 1 times 1.1 to the t. I better solve this to see when it hits 250, right? If I start with $1, how many years is it going to take for this to become 250? Set it equal to 250 and solve. So T ln 1.1 equals ln of 250. Let's solve. Ln 250 divided by ln 1.1. Ln 1.1. 57.93 years. T equals 57.93. So the A of t function is also a tiered function, and it's equal to 1.1 to the t power. This number before that is just 1, because remember, with little a, you're just starting with $1, right? Yes or no? For t less than or equal to 57.93. And for t greater than 57.93, what will it be? Somebody help me.
T minus
1.08 raised to the t minus 57.93. And is there a coefficient in front of the 1.08? How much money are you starting with at 57 years? 57.93. There you go. Get it? So, is 100 times this function equal to my capital A 100 of t? The answer is no. Look, these are different, right? So we have just shown that A k of t is not equal to k a of t, because a 100 of t is not equal to 100 times this little a of t function that I just created. Are you with me? Any question? You're going to ask me when you're lost, right? You're not just going to suffer in silence, because otherwise you're going to be suffering all semester long. Just ask me and get it over with. Yes, sir. What came out to be integral? The t doesn't have to be an integer. Compound interest works for even fractional parts of the year. Right? When your bank gives you compound interest, you don't have to wait till the end of the year to get interest on your money. They'll give you interest to the day, to the moment, right? So this is saying 9.61 years. This is saying 57.93 years. You don't have to round up or down or anything like that. Any question? Yeah?
How come in the simple interest one we did the two different cases of remaining in the same account and assuming you're reopening an account, but this one we did it?
So for compound interest, and I'm going to go into that in great detail, for compound interest, the effective interest rate remains constant. Whereas for simple interest, the effective interest rate is monotonically decreasing function. Let me explain to you what I mean by that. Let's say that you put in $100 into your bank account, and it's earning 5% simple interest, suppose. The first year you earned $5, and you invested $100. The next year you earned $5, but your balance at time one was 105. So in effect, the interest rate that you earned is less than 5% for the second year, because you have more money in there. You have $105 in there, and they're only paying you $5. Then the next year, you have $110 in there, and they're only paying you $5, so the effective interest rate for the third year is even less than it was for the second year, right? So I needed to explain that from the consumer's point of view, why would you leave your $250 in there when they're giving you interest only on $100, and that too at a lower interest rate of 8% rather than 10%? Here, completely different story. It doesn't matter. You don't have to pull out your money and reinvest it in order to keep having it grow. Here, the interest rate is constant, and I'm going to prove that today if I get to it. Okay? Does that help you understand? So for simple interest, it's much better every year you take out your money because the highest interest rate is in the first year. After that, the effective interest rate only decreases, and that's not good for the consumer. Get it? Okay. Can we do the next one now? Can we do the next problem quickly? Here we are. So first you want to see how long it takes 1800 to turn to 2000, correct? So find A 1800 of t. First, see how long it takes 1800 to turn to 2000. At what percent, guys? 2%. Compound, right? So 1800 times 1.02 raised to the t power equals 2000. Let's solve. 1.02 to the t equals 10 over 9. T ln 1.02 equals ln 10 over 9. Let me do it. So ln of 10 divided by 9 equals, and then divide that by ln of 1.02. 5.32. That's what I got for t. Did you? Great. So, what's the function? Or what should I do next? Leave the function alone. What should I do next? I know that it takes me 5.32 years to hit 2000. So I can start building the function if you please, if you want to do that. A, what's my k? 1800. A 1800 of t equals 1800 times 1.02 raised to the t power for t less than 5.32. Less than or equal to 5.32, let's say. Then what? Then what should I do? Next, what should I see? How long does it take 2000 to turn to what? 5,000. So how long for 2,000 to turn to 5,000? At what percent? Okay, so 2,000, 1.03 to the t equals 5,000. Solve. So t ln of 1.03 equals ln of 5 over 2. So t equals, let's do it, ln of 2.5 divided by ln of 1.03, 30.99. Okay, so let's keep building this function here. What should I put now for this A1 1800 of t? What should go here?
2,000 times 1.03
T minus 5.32. And for what interval? For what interval? T between what and what?
between 5.32 and 31.
T between 5.32 and what?
What's the decimal? 30, I said 31. I think it was 99.8.
I don't mind that you said that, but that's not the right answer. That's why I stopped. 30.99, is that right?
Oh, you added to 5.32.
There you go. 30.99 years more than the original 5.32 years. Get it? Because it was an additional, pardon me?
Oh, my question was why we added it.
Yeah, we're adding it because you're saying that after the first 5.32 years, how many years additional? So it's 30.99 additional years, right? So that would be t equals 36.31. So all said and done, this is the function for 5.32 less than t less than 36.31. Get it? And I'm not even done, right?
Could we have calculated 36.31 like previously when we calculated 30.99? Could we have just made the original function t minus 5.32?
T minus 5. Yeah, of course you could have. You could have. So it's pay me now or pay me later. Do it right away or just add it at the end. Doesn't matter. Yeah, you could have. Okay, then what? Is there a third tier to this function? Okay, and what might that be?
5,000 times 1.04 to the t minus 36.31.
Very nice. 4.
T is greater than 36.31.
T greater than 36.31. Excellent. Are you with me? Okay, now I want to show that that's not equal to 1800 times A of t. How do I do that? Let's create A of t. So this is page 1A. Let's just circle this so it's not in the middle of all my work. I want to come up with A of t. What is little a of t? What if I were investing $1? What would A of t be?
1 times 1.02.
Right, 1 times 1.02 to the t power. Set this equal to 2,000. I want to see how long it takes a dollar to get to 2,000. So t ln 1.02 equals ln 2,000. Solve this. You're going to get t equals 383.8 years. Let's see. Ln 2,000 divided by ln of 1.02. 383.83 years. So certainly A 1800 of t is not equal to 1800 times A of t. right? Let's go to the next page. Do you have any questions on this before I move on? This is just 3 tiers before it was 2 tiers, right? Yes, sir.
For the second part, like, are we can we only use 2%, or will we also be able to use 3% or 4%?
It depends on what your balance is, right?
Yeah.
So if your balance is between 2,000 and 5,000, you can only use 3%.
Okay.
Because that's what it pays. Yeah. Yes.
How much do you care about like the less than versus less than or equal to? Like,
Oh, was I not precise? Let's see.
yeah, for me it's kind of a little.
Yeah, for me it's shady too.
Okay.
No worries. So how about we put it here and then greater than? Okay?
This isn't inclusive, right?
This is inclusive here. This is not. Let's see. For accounts between 2,000 and 5,000 inclusive. Okay. So let's make this less than, strictly less than. Strictly less than. And then the first one should be less than. Less than. This one should be, okay, good. 5,000 inclusive, so this should also be less than or equal to, right? And then this one should be greater than. Thank you. Thank you for that. Yeah. Question? Let's go to the next page. What is the amount function for 1,000 invested at time 0, which gains $250 per year in interest payable only at the end of the year for 3 years? Can you draw it for me? Take a minute, draw this function. I want a 1,000 of t, where 1,000 is invested at time 0, and it gains $250, but only at the end of the year. No interest the whole year. The interest is payable annually at the end of the year. Can you draw me a function? So interest is not accruing continuously. But rather in finite segments with no interest between interest payment dates. So what does that look like? Let's see. Here's time 0. How much am I starting with at time 0? Yep, 1,000. So what kind of a function is this? Step function. Nice. So there's nothing happening up to time 1. But at time 1, it will pay you interest. How much interest? $250. So what's your A 1,000 of T at time 1? It jumps up to 1,250 because it pays you the interest. And then it stays flat until time 2. No interest here for the whole second year, but at the end of the second year, it will pay you interest. So how much do you have?
1,500.
Very nice. And then that continues to time 3, and so forth. But then what happens? Only at the end of year 3, for 3 years, it stops. So after 3 years, what happens? At 3 years, it jumps to 1750, right? But then what? No more. No more interest. It stays flat. It says, what is the amount function which gains $250 per year in interest payable only at the end of each year for 3 years? No more interest after that. So it stays. Agreed? Let me write this amount function. A 1000 of t equals, let's be careful with our equalities now, right? The inequalities. So 1000 for 0 less than or equal to t less than 1, and 1250 for 1 less than or equal to t is less than 2, and 1500 for 2 less than or equal to t less than 3, and 1750 otherwise. Agree? So this is a step function. What would this function have looked like if interest was accruing continuously? What would it look like? It gains exactly $250 per year, so it stays flat.
Straight line.
Linear. It would be linear, right? So it would look like this. Continuous interest, which is not for this problem, but I thought I would mention that, right? We said, right, simple interest is linear. Isn't this simple? They said every year it makes $250. That's simple interest, right? Linear function. Everybody good? Okay, let's keep talking. So it says the effective interest rate over the interval T1, T2 expresses the amount of interest paid or earned over an interval T1, T2 as the percentage of the initial balance of the loan at T1. So that's why this thing is bold. It's saying the interest rate is the amount of interest, which is the difference between the accumulation function at T2 and the accumulation function at T1. So here's the amount of interest divided by the initial balance, meaning at the beginning of your interval. If AK of t is not equal to KA of t, then the investor considers his effective interest rate over the interval T1, T2 to be capital AK of T2 minus AK of T1. So now I'm dealing with the amount functions, and this, of course, is just the interest earned again. So it's saying if you want to deal with the capital A's, take the amount of interest earned and again divide by the initial balance. Denote I sub n as A of n minus A of n minus 1 divided by A of n minus 1 to be the effective rate over the nth interval. So the nth interval is the interval between n minus 1 and n, just as the first interval is the interval between 0 and 1. The second interval is the interval between 1 and 2. So the nth interval is between n minus 1 and n. Are you with me? Where n is any positive integer. So couldn't I say this? In times a n minus 1. I'm going to take this thing and I'm going to cross multiply. In times a of n minus 1 equals a of n minus a n minus 1. Let's gather up all the terms a n minus 1, a n minus 1. So let me bring this one over. So a n minus 1 times 1 plus I n equals a of n. So this is saying the accumulation function at n is equal to the accumulation function at the previous time period, which is n minus 1, times 1 plus I. So this is a recursive relationship, a recursive function. If you want the accumulation at time n, simply take the accumulation function at the time before and grow it by 1 plus I. So this is saying a of 0 is 1. A of 0 is always 1, right? It's defined that way. That's the accumulation function. A of 0 is 1. A of 1, I'm using this, okay? A of 1 is equal to A0 times 1 plus I1. And then A of 2 is equal to A of 1 times 1 plus I2. But A of 1 is equal to A of 0 times 1 plus I1, and then I have 1 plus I2. Are you with me? Yes or no? Keep going like this. A of n is equal to A of 0 plus, no plus, 1 plus I1, 1 plus I2, no plus, 1 plus IN. So I should really make dot, dot, dots there, okay? Because it's not the very next term. Let's fix that once and for all. Like so. Follow me? So how about I just say it's the product. Let's not call it I, let's call it J. J equals 1 to n of 1 plus I sub j. Because this guy is 1, so I don't have to worry about him anymore. So 1 times 1 plus I1 times 1 plus I2 plus 1 plus I3, blah, 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 dot, 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 right? What am I trying to say here? Do you get where I'm going with this? What if you had something that looks like this? I need a clean piece of paper to write. Let's say that I start with $100 at time 0. And for the first year, my interest rate, compound interest, okay, is 2%. And then I'm at time 1 now. Time 2 and time 3, this 2-year period here, the interest rate is 4%. What is the balance at time 4 if the interest here is 7% and the interest here is 9%? Okay, so let's not say time 4, let's say time 5. Find me the balance. In other words, I want a 100 of t, where t is 5. So a 100 of 5. Can you find me a 100 of 5? So by what I have done down here on the previous page too, it's saying just take what you have at time 0 and grow it by that interest rate, whatever the interest rate is, right? So it's as simple as doing this. A 100 of 5 is equal to 100 times 1.02 to the 1, 1.04 to the 2, 1.07 to the 1, and 1.09 to the 1. So I'm saying this interest rate applied for a year, and this 4% interest rate applied for 2 years. Let's go like that. And 7% applied for the next year, and 9% applied for the following year. So using that recursive relationship that I came up with a minute ago, it says just take A of 0. Here's your A of 0. It's 100 times 100. So this is your K times A of 0, right? That's 100. Because this guy is 1, always. Times the interest rate in the first year plus 1. The interest rate in the next 2 years plus 1, raised to the 2 power, because that's going on for 2 years. Follow me? That's how I use that recursive relationship. Get it or no? What's your question, guys? Any question? Does it make sense? Yes, sir.
The exponent.
Hmm. So I'm saying 2% for 1 year. So 1.02 only to raise to the first power because it's only happening for 1 year. This 1.04 times 1.04 because this interest rate is 4% and this interest rate is also 4%. So I raised it to the 2 power instead of writing it 2 times. Any other question? Okay, and let's just finish up that previous page. So it says here, suppose that your accumulation function is linear. For every dollar that you invest at t equals 0, you earn s dollars for each year that it is invested. So I just want to draw this function. Little a of t. You start at 1, and it grows. It's a linear function. A of t equals 1 plus st. We know this already. We used to call it I. Now I'm calling it s because it's simple interest. And if I wanted to draw a k of t, versus t, I would start at k. And the slope would be ks because ks equals the slope. Here, s equals the slope. Because here, ak of t is equal to k times 1 plus st. So I have k plus kst, making the slope equal to ks. Yes.
No, I just want to move on.
Simple interest. I'm just drawing the amount function. This is the amount function. This is the accumulation function. The difference is that here I'm starting with $1, here I'm starting with k dollars. It's still linear, simple interest in both. Yeah.
Can you pull it a little bit to the
Of course.
On the right-hand graph, why is this still KS and not S?
Because when you distribute this, k times 1, you get k. And when you distribute this, you get kst.
Oh.
So the stuff that comes before the t is the slope, right? Because I'm comparing to y equals mx plus b. So my b is k, that's the y-intercept, and my slope is ks times t. Get it? What's your question? Next one, next page. Draw and describe the accumulation functions for simple and compound interest. So simple interest we already know. How about we draw them both on the same graph? Accumulation functions. So they're asking for A of t versus t. Simple versus compound. Let's go. Simple interest looks like this, right? Starts at 1 and goes up. What's the slope? The slope is s, or lowercase I for simple interest, which we call s, right? Are you with me?
Yep.
So this is A of t equals what? What's the function? 1 plus what? it, or 1 plus st. Doesn't matter what you call it, right? 1 plus it equals 1 plus st. I'm calling it s because I want to show that it's simple interest. Okay, what about compound interest?
Exponential.
Exponential, thank you. Like so.